RF power measurements using any of LadyBug Technologies' RF power sensors and LadyBug's high-speed data logger. The demonstration setup consists of an LB680A RF power sensor connected to an LB2A microwave source. The demonstration source emits 1.9 gigahertz in a CW signal format or an 11 microsecond pulse. Okay, now we'll start the high-speed logger. We'll do that in the Start menu, LadyBug Technologies, High-Speed Logger, and we'll launch the application. Now we're going to start the test. First, we'll select the Measurements tab and set the frequency to 1.9 gigahertz so we have accurate measurements. We'll make sure we're in CW or average power. Then we'll set the measurement to start when we click the Start button with the mouse. We'll set the measurement to stop after 100 measurements are made. These are going to be fairly long measurements. We'll set the measurement spacing to be 100 milliseconds. That'll give us a 10-second test in total. Now when I start the test, the source is in high power mode. I'm then going to manually switch it to low power and then back to high power, and it'll create kind of a man-made pulse that we can view and examine the results of. Now the test is running right now, and in a minute you'll see the results. When the logger finishes, it opens the text file which has all the data that's been collected, and you can see it here. In fact, if you look, you can see right in the middle the time at which the power was low. Now what we're going to do next is close this file and open a spreadsheet. Okay, now we will open the file in an Excel spreadsheet. The file is located on the desktop, and you can select to name it anything that you want, but ours is the name I've selected here. The data gets converted into Excel's format, and here's the column of data. The column on the left is the index, which is generated by the data logger. We're not going to use that column. We'll just use the time and power level, which I've selected here. And now we'll insert a scatter graph, which is a nice choice to use as a graph. I'll zoom it up so that you can get a better view of it. And you see it's a nice negative going pulse on a real slow time frame that I selected. You'll notice each of these dots are the actual measurement points. Now this sensor and this logger is capable of measuring much faster than this particular measurement that we've set up here for demonstration purposes. Okay, now we'll do a different measurement this time. We'll set the sensor up to make peak and pulse power measurements. Let's set our averages to 20. And we're going to start the measurement when the button's clicked. And we will stop after 20 measurements. And we will make those measurements every 500 milliseconds. That'll give you the sensor time to get a good pulse power, and I'm going to count to 5, and then I'm going to switch the pulse on. At first there'll be just a CW signal. So here we go. We're making the measurements now with no pulse. I've clicked the pulse on, and we'll see what we get when the time is up, and here it is. So you can see there are 20 measurements, and here's where the pulse was switched on. Prior to the pulse being on, the peak and pulse power are almost identical. The duty cycles are 100% because it's a CW signal. And now you'll see the pulse is a little over 11 microseconds in pulse width. So you can do a lot of different things with the data logger for various applications. In conclusion, LadyBug's high-speed logger adds a tremendous amount of flexibility to its line of RF power sensors. The logger can measure various types of power measurements, including peak and pulse power measurements and CW measurements. Measurement intervals can be set, the measurements can be triggered by various events, and measurements can be done for long periods of time or very short periods of time. Thank you for watching our video.